Hi everyone, we're going to show that each sequence is geometric, and we're going to find the common ratio and write out the first four terms. Before we get started, I'm going in order for the slides this way. I'm going down like this. So this would be 4, and this would be 5, 6, 7, 8. So there's going to be 10 of these. And if you know how to, the first ones are easier. This set is a little easier. And this is a medium. And this set would be the harder set. And basically, if you already know how to do some of the easier ones, then you could probably skip the slides and go to the harder ones. Our common ratio on these, looks like this easy set. Our common ratio for number 1 would be 3. For 2 it'd be -5. For 3 it'd be 1/2. And for 4 it'd be 5/2. So all of these are exponential. So all geometric sequences look exponential. So let's go ahead and get started. We're going to do this first step, and the second step, and then the third step. Okay, so the first one we have is, we got to find our r. So if we have 3 to the n, then our next term is going to be 3 to the n plus 1. And the way you find your ratio, for example, if I had 3 and then I had 9, then your ratio would be 9 over 3. You take your next term and divide by that, and you get 3. So your common ratio would be 3, because 3 times 3 equals 9. So that's what I'm doing here. So you're going to take your previous term, or your next term, and divide it by your current term. So we're going to take our ratio is 3 to the n plus 1 over 3 to the n. And using our properties of exponents, this would be, my base is 3. And you subtract this power, n from this power. So it's going to be n plus 1 minus n, which gives you 3 to the 1, which equals 3. So that's your common ratio. Alright, and then we have to, it's geometric because it's constant, and we have to find the first 4 terms. So our first term is going to be 3 to the 1. Our second term, and I'm looking at this right here, is 3 squared, which equals 9. Our third term is 3 cubed, which equals 27. And our fourth term is 3 to the 4th, which equals 81. Okay. The next one, we have, the problem's going to be -5 to the n. So we're going to do the same thing. We're going to take -5 to the next term over -5 to our current term. And use your quotient property of exponents and subtract the powers from each other. And this is going to give you -5 to the first term. So this is how you get your r. That's your r. Then I'm going to use this, my sequence, and find my first 4 terms. So the first term would be -5 to the first. The second term is -5 squared. And the third term is going to be -5 cubed. And the fourth term is -5 to the 4th, which equals -5, 25, -125, and 625. Okay? The next one we have is, sorry, I have a cold today. Our next one was -3 times 1/2 to the n. So what I'm going to do is find the ratio. Whoops, sorry. And I'm going to do the previous term. The next term would be, my r is negative 3 times 1/2 to the n plus 1 over negative 3 to the 1/2 to the n. Now, the negative 3's cancel here, so I'm going to use my quotient property and get n plus 1 minus n, which gives me 1/2 to the n. And that's your common ratio, 1/2 to the 1. So that's your r. Now we're going to write out all the terms. So we have a sub 1 equals negative 3 times 1/2 to the first power, negative 3 times 1/2 squared, negative 3 times 1/2 cubed, and our fourth term is negative 3 times 1/2 to the fourth, and this is going to equal negative 3/2 equals negative 3/4 equals negative 3/8, and this one's going to be negative 3 over 16. Okay, my next one is, my sequence is 5 over 2 to the n. It is geometric, so we can just go ahead and write this to find r. 5 over 2 to the n plus 1 over 5 over 2 and to the n. And you're going to simplify, and when you get that, you get 5 over 2 to the n plus 1 minus n, which equals 5 over 2 to the first power. That's your common ratio, and you just write out your first 4 terms. So that's 5/2 first. And you just write everything out. 5/2, 25/4, 125 over 8, and 625 over 81. Okay, the next set is more the medium set. It's going to get a little harder. And my term is, my sequence is 2 to the n minus 1 power over 4. So I'm going to do the next term. So my next term would be 2 to the n minus 1. Then we're adding 1, because that would be the next term, over 4, over my current term, which is just that one. Okay, in this case, the 4's will cancel, and you just get, so the 4's cancel here, and you're going to get 2 to the n over 2 to the n minus 1, and you subtract using your quotient property. Make sure you use parentheses here, so you're going to get 2 to the first power, because this would be n minus n plus 1, so that cancels. Alright, so that's your common ratio, and then you just find your 4 terms and plug in your numbers. So this is 2 to the 1 minus 1 over 4. Should have left more room. Alright. Then we have a sub 2 is 2 to the 2 minus 1 over 4. And a sub 3 would be 2 to the 3 minus 1 over 4. And a sub 4 would be 2 to the 4 minus 1 all over 4. And when you simplify this, you're going to get 1/4. This is 0. Anything to the 0 power is 1. And this is going to be 1/2. This is going to equal 1. And this one's going to equal 2. Okay, the next problem is very similar. We have our sequence as 3 to the n over 9. So my next term would be 3 to the n plus 1 over 9. You're just adding the 1. So to find your ratio, you're going to take your next term, divide it by your current term, and here the 9's will cancel, and so you're going to get 3 to the n plus 1 minus n equals 3. So 3 is your common ratio, and then you just find your 4 terms, and you're just using these index numbers to plug in. So you get 3 to the little 1 over 9, 3 to the little 2 over 9, 3 to the little 3 over 9, and 3 to the little 4 over 9. So this is going to be 1/3. This is going to equal 1. This is going to equal, let's see, 27 over 9, which is 3. And this one's going to be 81 over 9, which equals 9. And the next one I have is 2 to the n over 3. So the next term's going to be, so you do your common ratio, it's going to be 2 to the n plus 1 over 3, divided by 2 to the n over 3. So when you find your ratio, you're going to use your quotient property, 2 to the n plus 1 over 3 minus n over 3, which is going to give you 2, you can write it this way, n plus 1 minus n all over 3. The n's will cancel, so you get 2 to the 1/3 power. That's your common ratio. Now, to find all your terms, a sub 1, a sub 2, a sub 3, and a sub 4. By the way, when teachers say a sub, they're saying a sub subscript 1, a sub 1. Alright, so we get 2 to the 1/3, 2 to the 2/3, 2 to the 3/3, and 2 to the 4/3. And this one equals 2, because that equals 1. Okay? And the next one we have is our sequence as 3 to the n minus 1 over 2 to the n. So our next term is going to be 3 to the n plus 1, which, sorry, I cleared the page. Let me do it again. So I have 3 to the n minus 1 all over 2 to the n. So my next term would be 3 to the n minus 1, then you have to add 1. And the denominator is going to be 2 to the n, and you have to add 1. So this is going to be 3 to the n, and the denominator is going to be 2 to the n plus 1. So when you do your common ratio, we're going to do our next term, divide it by, now this is going to equal 3 to the n. Basically what I'm going to do is I'm going to write this as 3 to the n over 3 to the n minus 1, and I'm going to multiply it. I'm flipping this. Instead of dividing, I'm going to flip this as 2 to the n over 2 to the n plus 1. So basically I'm just taking this and dividing by this. And then you flip it. Remember how you flip it when you do that. So then you're going to get 3 I'm going to take care of this part first. 3 to the n minus n minus 1 times 2 to the n minus n plus 1. And that's going to give you 3 to the first times 2 to the negative 1. Because this right here equals negative 1, which equals 3 over 2. So that's your common ratio. And when you plug your terms in, you can plug it in. You're going to get a sub 1 is going to end up being 1/2. A sub 2 is going to be 3/4. A sub 3 is going to be 9/8. And a sub 4 is going to be 27 over 16. You're just plugging in these index numbers here. Alright. And the last one we have is 2 to the n over 3 to the little n minus 1. So we know our ratio is going to be 2, our next term is going to be 2 to the n plus 1 over 3 to the n plus 1 minus 1 divided by our sequence 2 to the n over 3 to the n minus 1. And again, we're going to do the same thing we did last time. This is going to equal 3 to the n minus 1 over 3 to the n times 2 to the n plus 1 over 2 to the n. And this is, use your quotient property, you're going to get 3 to the n minus 1 minus n times 2 to the n plus 1 minus n, which gives you 3 to the negative 1 times 2, which is 2/3. So our common ratio is 2/3, and it's constant, so it's geometric. And then you just plug in your index numbers here, and you get a sub 1 is 2. A sub 2 is going to be 4/3. A sub 3 is going to be 8/9. And a sub 4 equals 16 over 27. And that's all. Thank you and have a nice day. Bye-bye.